Hey, we're back again, and yeah, on this video we'll just be looking at the application of the few theorems that we've covered up to so far. So one more theorem before we continue is the one which states that equal chords subtend equal angles at the circumference of the circle. As you can see, we have these two chords right here, which is chord, I can call this one chord AB, and that is called CD. So it is given that AB is equals to CD. So these ones will subtend equal angles at the circumference. In fact, this is the only theorem that allows you to have equal angles at the center. It also states that equal chords subtend equal angles at the center of the circle, which means this angle will be equals to that, provided that this chord right here is equals to that chord right there. As you can see, that's the reason to use equal chords, equal angles. Okay, so you don't need to know the proof of this. Now let's quickly dive into the application of this. As you can see here, we are given O, which is the center of the circle, and all that information, and we should find those angles A, B, C, D, E, F, and G in that order. Okay, so let's first find angle A. We go to A, we mark that, we trace back like I said, which takes us to point T. We trace back, takes us to point V. Right, so A is subtended by arc VT or chord VT. Then at the same time we have the chord VT subtending 70 degrees, the angle 70 degrees at the center. So in fact, that 70 degrees is twice A. So 70 degrees is equals to 2 times angle A. Right, and this is angle at center, which is equals to what? Which is equals to 2 times angle at circumference. Okay, and then from here we have that A will be equals to 35 degrees. Once we have A, now we need to find B. If you look at B, we trace back again. B was subtended by those 2 points, or by that chord TR. But that chord TR VT is given to be TR. So since those chords are equal, they subtend those angles. Angle what? Angle A and B respectively. So angle A is equals to angle B, and both of them should be equals to 35 degrees. And then the reason for this is what? Equal chords subtend what? Subtend equal angles. So it's equal chords, equal angles, like that. Okay. And now that we have those two, let us go find angle C. If you look at angle C, it's always about tracing back. You trace back to the circumference, find the 2 points that make up that angle. So angle C, when we trace back, we can see that it originated from those 2 points T and R. Which other angle is subtended by that? It's that whole angle Q. So if you look at that, you will see that angle C and angle Q should be equal to each other. And those are angles in the same segment, right? So angle P should be equal to angle Q. Why? These are angles in the same seg. Alright, so by default this will give us, this is angle C. As you can see, Q is equal to A plus B. So it's angle A plus B, which is 70 degrees, 35, 35. Then angle D, where is D? There. We trace back always. When you trace back on D, you will see that this originated from that and that. Now, which other angle is subtended by the very same chord VT? VT subtends angle A. We've seen that. So angle D is equals to angle A, and they should both be equals to 35 degrees. Why? These are angles in the same segment. Okay. So furthermore, what do we have? We now have D. We should find angle E. But then, lucky for us, they told us that VT is equals to TR, which is given. So by default, that's an isosceles triangle, which means angle E is equals to angle D, and they are both equals to what? They are both equals to 35 degrees. Why? These are angles opposite equal sides, right? And we should now focus on finding angle F. How will we find angle F? As you can see now, F is this whole angle here. So when we add D plus E, angle E plus D plus F, they should all give us what? They should give us 180 degrees. And these are angles in a triangle. So once we have that, we should be good, because we have E and D to be equal to each other. In fact, both of them are 35, which means combined they are 70 degrees, plus angle F, which is 180 degrees. So angle F, which is going to be 180 minus 70, which is 110 degrees. and lastly we should find G. So we go to G. G is this angle right here. Tracing back, we can see it was subtended by that arc PQ, but the very same arc subtends another angle there, which is R at the circumference. So angle G is equals to 22 degrees, and these are angles in the same segment. So this is how you apply that. Okay, furthermore, let's look into this exam problem right here. In the figure, O is the center of the circle. A, B, C, D, and E lie on the circle such that chord AB and DC are equal in length. So we have equal chords. Remember, we said if the chords are equal, they subtend equal angles at the center and also at the circumference. Right, angle AEB is 39 degrees. So first find angle O1. If you trace back on O1, you will see that O1 was subtended by that chord AB at the center. Right, O1, which is the central angle, but the very same chord subtends another angle at the circumference. Butterfly, as you can see, O1 will be twice of E. Right, so angle O1 will be equals to 2 times what? 2 times angle E. Right, and this is angle at center, which is equals to what? Which is equals to 2 times angle at circumference, as we've seen in the previous video. Right, so angle O1, which should be 2 times 39. 2 times 39 degrees, we should be 78 degrees. Makes sense. Right, so that's what we have. And then let's find O2. O2, angle O1 will be equals to angle O2. Why? Because these are equal chords subtending equal angles at the center now. Equal chords, equal angles. Right, like that. Moving on, let's look into another one. Which one does this look like? In the diagram, S is the center of the circle. PQRT, okay, that's the circle PQRT. PT is a diameter, at least we have a diameter, and then a diameter in the center there. Okay, so RST is equals to x minus 8. Okay, that is that angle there, which is x minus 8 degrees. A PQR is equals to 2x minus 40. So that's the angle which is subtended by P and R. But then if you remember, we spoke about the diamond thing in the previous video, whereby we said this chord subtends 2 angles. It subtends this angle firstly here, and it also subtends another angle, which is what? Which is this one, the reflex, top and top, right? So in fact, this whole angle right here, we can calculate that angle to be equals to what? Remember, this is 180 degrees. So this is going to be 180 degrees plus that smaller angle there. Okay, so in fact, we can calculate the angle of, determine the value of x, which means we are looking for x. But the angle PSR, there's 2 angles there. I'm being specific that it's PSR reflex, which will be equals to 2 times angle Q. Why is that? This is angle at center, which is equals to what? Which is equals to 2 times angle at circumference, like that. So, but we do have PSR. PSR is made up of 2 angles. This is made up of PST plus what? Plus the angle which was given to us, the RST, plus angle RST. So it's a combination of those two, which will give us 2 times angle Q. Angle Q is 2x minus 40 degrees. That's what we have. But PST is none other than a straight line. So that's 180 degrees plus RST, which is x minus 8 degrees. And this will give us this times that, which is 4x. This times that, which is negative 80, like that. Okay, so 180 minus 8, which is 172 degrees, plus x, which is equals to 4x minus 80. Okay, now you need to keep variables one side and constants one side. Bring the 80 this side, which gives you 172 degrees plus 80 degrees, which is equals to 4x minus x. Right, so when you quickly do that, is 172 plus 80, which is supposed to give you 252. So this is 252 degrees, which is equals to 3x. Divide this side by 3, divide that side by 3. Hence x is equals to 252 divided by 3, which is 84 degrees. So the angle x is equals to 84 degrees. Okay, let's move on. Then we have this one. Let's look into that problem. O is the center of the circle. TNSPR. POS is 60 degrees. There's POS, which is a central angle, as you can see. PS is equals to NT. So this chord right here is given to be equals to that chord. So this chord subtends this angle, but that chord subtends another angle, which is that. In fact, R and S should be equals to each other based on the theorem that says equal chords subtend equal angles at the circumference of the circle. So first things first, calculate angle PRS. Where's PRS? PRS is this one, as you can see. But then PRS is subtended by which chord? It's subtended by PS, and the very same chord PS subtends another angle, and PRS is at the circumference. It subtends another angle at the center, which is 60 degrees. So in fact, to write it smoothly, remember we said the angle POS has to be twice what? Has to be 2 times the angle PRS. Need to identify which one is at the center. So that's PRS. Right, what's the reason? This is angle at center being twice angle at the circumference. 2 times angle at circumference, like that. Okay, so POS is given to be 60 degrees. So 60 is equals to 2 into PRS. As you can see, divide both sides by 2. You will get that PRS will be 60 divided by 2, which is 30 degrees. Okay, and then what else do we have? NST. What's angle NST? Angle NST is this angle right here. So it's pretty much straightforward. As you can see, NST, angle NST has to be equals to angle PRS. Why is that? Because equal chords subtend equal angles. So this is equal chords and equal angles. Equal chords, equal angles. Alright, which means NST has to be equals to 30 degrees as well. Yes, so let's look into this one. In the diagram below, O is the center of the circle, and then diameter LR. So at least we have a diameter on this one. We already know one thing. Once we have a diameter, there's a 90 degrees where this is a 90 degrees right there. Okay, so at least we have a 90 here for angle K. N is another point on the circumference, and chord LN and KN are drawn. L1 is equal to 58 degrees. So let's see. Calculate angle LKR. LKR, which is none other than the whole angle K. So LKR should be equals to 90 degrees. Why? These are angles on a semicircle or angles on a diameter, like we said. Right. And then what else do we have? Find angle R. They are looking for this. But if you look at that triangle, you can see that in fact, in triangle what? LKR, we have what? We already have 2 angles. So in fact, angle R will be none other than what? 90 degrees minus 58 degrees. Right, and these are angles in a triangle. So 90 minus 58, which should be 32. So that's 32 degrees, right? And we have to find angle N. If you look at angle N, it's that. So we trace back. When you trace back, you will see that angle N originated from chord what? LR. So angle N, which is at the circumference, but the chord also subtends another angle at the circumference, which is angle R. So angle N will be equals to angle R, and both of them should be equals to 32 degrees. And they are actually angles in the same sec. Alright, just like that. Okay, now moving on. Okay, yeah, that's pretty much how you apply the first few theorems. Catch you on the next one.